is. Here we go. The first part of this is being able to describe key parts of this, and we're going to kind of break it down into more simpler ideas. But the first thing we're going to discuss is blank is a collection of distinct objects. What we call that is a set. A set is a collection of distinct objects. Okay, and right up above this, if you have room, put this in here. You don't need to do it, but let's look at two sets of here, like a Venn diagram E kind of thing. Where let's get rid of that A. Let's say a set of something can be like fruit. Can someone give me another set of something else? Vegetables. Veggies. Okay. So those are sets we can come up with. Can someone give me another set of something?
Grape.
Not great. That falls in the category. Meats.
Meats, yeah. Oh, protein.
Dairy. Protein. So we can create different sets for different objects in them. Each object in a set is called, so let me make sure, is called an element. The periodic table is a set of elements. You can think of it that way. Right, there's that cam right there. What's up? Can we describe some elements in each set? Can someone give me some elements of fruit? Apples. Pears. Grapes. Kiwi. Yes?
Watermelon.
Okay, watermelon. Okay, well, we're okay with that. Can someone give me some other elements of a vegetable?
Celery.
Carrots.
Spinach.
Green bean.
Broccoli.
Celery.
Spinach. Celery. Bell. We can come up with different things that represent different parts. Is there something that exists as a both vegetable and a fruit?
Tomatoes.
Tomatoes are definitely one of them. It's a fruit and a vegetable. Surprisingly, it's a fruit and vegetable. By definition of a fruit and vegetable, it is. Avocado.
Because it's a vegetable, but
It has a seed. It has seeds in it.
so tomatoes are fruit because tomatoes are
Also, take out the bell.
It's okay. We're fine here. You guys we can argue about this the whole time. Yeah, we're not going to do that. But we can have them fit into both categories. We can say a fruit is a tomato, a vegetable is a tomato. Okay, we can separate these ideas. Okay. Now, if we're looking at this overall set, we're looking at this outside thing. We also want to be able to put in things that are not fruits and vegetables. What is not a fruits and vegetables that we consume, I guess? Candy. So I'll accept that. What's another thing? Wheat, bread, grains. What's another thing? Meats. Meats are, it's a good one. Another one would be liquids. Dairy products, whatever. ID. We could. We don't consume oxygen in that way.
Yeah, we do.
No, we don't eat oxygen. You can't survive off of just eating oxygen. Okay. Someone said sunlight. I'm like, do you look in the sun and go, I'm going to absorb this? Yeah, but we're not plants.
You're taking vitamins. Isn't it vitamin D from it? Technically, you're taking vitamin D from it.
But you cannot sustain life without you can't just go out in the sun and go, I'm just going to have vitamin D for my food today. Technicality, leave me alone. Shush. Okay. Now, so we talked about these are everything included. So this is our universal set. Everything that we look at is also on the outside. The elements with no, or sorry, the set with no elements is the empty.
The empty.
Example, please.
The empty set. We're going to talk about that. And it's noted by a 0 with a line through it. And we'll just refer to it as that. It's not, 0 is not even included on that. Think of it like that. A 0 with the line included tells you that there is no elements, and 0 is not even an element in there. There's nothing. It means none. That little circle with the line through it means none, right? That's what it means. An example of this is, what is something that is not an element of our sets, of our from a universal set or the sets that we have up here? If it was that case, it would be candy, wheat, meat, and liquids. Right? What's another element that we don't consume?
Air.
Plastic.
Yeah, have you ever seen like My Strange Addictions?
Okay, again, technicality here. Right, everything outside of it would be, someone had this, would this be true or false? And this was a really good question. Is this okay? Someone said this is not a fruit and vegetable, we can consume rock.
Yeah.
Protein.
What specific rock do we consume? Salt. We consume rock on a daily basis. It's a mineral. You know, salt rocks. Oh yeah. Candy rocks, right? So it's a little bit different. It's crystallized sugar. Okay. So you can have everything that's not inside of our universal set, everything else that we don't look at. Okay. We don't consume plastics. We don't consume cardboard. We don't consume. Okay. The set of all elements under the consideration is called the universal set. It's denoted by capital U. Whenever we refer to this, we're calling the universal set of just U. Means everything. If we're talking about universal, we're talking about everything we consume. Dairy, wheat, vegetables, fruit, products, seeds, nuts, whatever, tofu, vegetarians, whatever works, we're considering that in that category. Whatever helps us to nourish our body, we're considering that in a category. Okay, that's what we mean by gelatin, right? Jello, consumed, right? So anything that fits in that category, we consume. What we use sets for, and what we're going to be able to look at some of these, and how these are situated with numbers. Sets are used to calculate probabilities. And we're going to describe these different types of things. You place your hand inside of a box containing 20 different fruits and vegetables. What's the likelihood you're going to pick up a banana? At random. At random. 20.
1 out of 20.
Depends on, I said, do you need to know how many bananas are? You need to know how many fruits are. You need to know how many kiwis are. Because what if I said, what's the likelihood of pulling a, let's say you put your hand in a box that contains 20 fruits and vegetables. Of the 20 has 1 orange and the rest are tomatoes. What's the likelihood of you getting a tomato?
Oh. Nice.
Depending on how I ask it, depends on the probability that I can give you.
Who said no?
Okay, and we're going to talk about contingent probability. Okay, and what it looks like, what happens when you change the probability of pulling something out of the box. What looks like probability when we're looking at a deck of cards? What's the likelihood of look at getting 21 on a deck, on getting straights, on getting full houses? Those are the kind of probabilities we want to look at. Okay. No blackjack. Texas Hold'em. Now,
Oh yeah.
this is the more mathematical side. We want to be able to set these up to describe We want to set these up to describe our probabilities. The set of A is the prime numbers less than 10. Can someone give me, what is a prime number? Raise your hand. One and itself. A number that can be divided by one itself that's less than 10. Can you give me those numbers? Well, 1 is one of them. 2 is one of them. 3 is one of them.
All the way up to 5.
Oh, okay.
6 is not divisible. 6 is divisible by 2. 4 is divisible by 2. 8 is divisible by 4 and 2.
9 is divisible by 3.
9 is divisible by 3.
11.
Is it less than 10?
Oh, 11.
Okay.
Negative.
Now, this describes a set. This describes a set. That's a set of our numbers. How many elements do we have of that set? How many numbers? 1, 2, 3, 4, 5 numbers.
Why doesn't it just say number?
Because it looks to be all fancy.
It has, when you're describing probability, it's required that you talk about it this way. Because if I could say how many numbers are in the set, numbers that are even, numbers that are odd, how many elements are in each? Are you looking at the lowest element, or are you looking at the highest? There's different ways you can perceive the answer. This one makes probability difficult, is because the way that I ask you determines the way that the probability comes out. Does that make sense? That's why I'm saying, how many numbers of the elements are in the set? Total elements. Okay. B is a set of even natural numbers less than 10.
2, 4, 6, 8.
2, 4, 6, 8.
Oh, so it's even.
Even. So we're creating these numbers. We're creating sets by the description that it's providing. How many elements do I have of that set? 4. Easy, right? It's not that we have 4 in here. It's that we have 1, 2, 3, 4 numbers in that set. Looking at the next one. C is a set of natural numbers less than 10 that are divisible by 4. Oh, multiples of 4.
1, 2, 4.
Multiples of 4.
Oh. 8.
4 is a multiple of 4 by 1. 8 is a multiple of 4 by 2. How many elements do I have?
2.
You see where we're going with this? We're just, what?
What do we do with that?
You get these.
I know. I don't know.
You're fine. Today's homework, if you flip on the back side, it already gives you the sets. You don't have to worry about it.
Whoa.
Trust me, we're building on this. This is why we're doing this. If you can just get it from here to here, we're fine. No. No. Universal set of numbers less than 10. Give me all the numbers that are less than 10. They're all natural.
109.
Less than 10.
9.
So you want that but 10 is not more than
Exactly. So all the numbers that are less than 10 that are natural. We don't have any natural numbers that are, natural numbers are always considered positive. You can't have negative apples.
Or decimal.
Can't have decimals. Whole numbers. How many elements do I have of this? 9. We are going to use these examples to set up the charts down below. So we want to be able to remember each A, B, C, and the universal elements. Does that make sense? This is where it gets confusing. Not by much, but it's important that you guys are able to pay attention to what's happening here. So let's look at the next one. I'm going to give you little excerpts in order to help you guys understand, because if you read the first set, C is a subset of set B if every element of C is also an element. Is that confusing?
Yes.
Yes. So I'm going to try to give you a basic understanding of basically what they mean if you do not understand it. Okay, it gives you the picture of it, it gives you the notation, and we're going to do an example using the products we did up above. Basically what it means is are all elements of C in B. Meaning, for it to be true, every single element must be in C, that's in C must be in B. We'll do an example of this so it's clear.
Oh, I get it.
Does everything of C happen to be in B?
No.
Let's look at it. Let's look at it. Let's look at it. You're doing a reverse. Now, the way that it's going to look is C a subset of B? This is the way that the notation is going to look. Does C go into B? Now, in order for us to determine that, we're just going to write out the elements. Our elements of B happen to be what? What was the elements in our example? What was it? 2, 4, 6, and 8? No, that's set. What is our set C? 4 and 8. Are the elements in C in B?
Yes.
4 matches up with 4 on the top. 8 matches up with 8 on the top. Yes, C is a subset of B. C can go into B.
It's just like the diagram.
The diagrams are gonna. This is kind of weirder, but it makes sense and it doesn't make sense at the same time. We don't care about that. We're only pulling a couple of these numbers. In this case, we're pulling to make C up. We're only pulling multiples of 4 and 8. So in this case, is 4 and 8 in B? Yeah. 4 and 8 are in B.
So what is the definition of subset?
Subset are the elements a smaller group of numbers that you pull from a bigger subset in it. If we look at just B, can you give me another subset of B? 2 and 6. Can you give me another subset of B? 2. Can you not give me a subset of B? 9. 10. Not in B. 2. 2's in it. Okay, so we're just looking at smaller numbers that are in the set. Don't let that confuse you. Okay. The next one we're going to do here is our intersection. Intersection of sets A and B is a set of all elements that are in both. Must be in both sets. For it to be an element of this, they must be in both sets. If they are not, they're not considered intersections. This is that are in both sets. In a Venn diagram, we're looking at the intersection where they both overlap. Right? Compare and contrast. What are their similarities? Similarities would be where the intersection would be. Again, we're going to write this out. Our elements of A was 1, 2, 3, 5, and 7. The elements of B was 2, 4, 6, and 8. What elements are both in A and in B? They must be in both. Just 2, right? The way that we want to write this. A intersect. It's not really a question. We're describing this. The first one was asking, is C a subset of B? That's an easy question we can ask. We always ask it as a subset, and it'll always ask you, is it a subset of something? This is asking you, what is the intersection? What are the elements of both A and B? Well, we're going to do more of that. Don't worry about the subsets right now. But as long as you can get everything else.
If the symbol you think is to the side, that means it's a subset.
Subset.
If it's down, it's intersection of the two.
Yep. So we want to say that the set of this would be 2. The way that I always look at this value here, I'm going to spell this out. What does this read as? And. If the upside down U is going downwards, I always think of it as and. A and B must be in bold. Has to be in bold. A and B. Okay. The next one. If it is going upwards, if we're looking at this union, we refer to it as union. Elements can be both. Elements can be both, either or.
What?
Either or.
They can be both.
If I give you this, and the question would be, you're given an apple. Do you want it diced in 4 pieces or 5 pieces? Why? How many people want it in 5? Why? Either or. Why does it matter? I just want them in smaller pieces so it fits in my mouth better. I want them in 5 pieces so I can dip them in peanut butter. Either or. Doesn't matter which one you choose. Would you rather have $1,000 in coins or $1,000 in bills? Why?
Because it's
Easier. There's no reason. It's still $1,000, right? Doesn't matter which one you have. Trying to think of a better way to explain that, but either or. So in this case, if we're going to set up this, we're going to do A and B again. If we're looking at this set, it is everything inside of our circles, both the intersection of these values. And it's crucial that we see it this way because it's going to be kind of important a little bit later. Anything that's in those circles, doesn't matter if they overlap. Now in this case, we're going to go ahead and write out all the elements that exist in both of them. A or B will be what numbers? 1, 2, 3, 4, 5, 6, 7, and 8. We don't need to repeat our 2's. As long as it's one element, we're just saying how many elements. Either or exist in both of them. Doesn't matter. Doesn't matter. Right? Either or. It can be either element. Doesn't matter which one you choose, can be either one. The last one here is called complement. Complement is everything else. Okay? It's everything not in our set. Okay? Everything not in the set. So we got to look at the universal portions of this. Our universal gave us 1, 2, 3, 4, 5, 6, 7, 8, and 9, right? Because we chose all numbers that are less than 10. A was what? 1, 2, 3, 5, and 7. What numbers are not in set A? Well, 1 is in the universal, 2 is in the universal, 3, 5, no, 7. So that leaves me with the remaining terms. This is 4, 6, 8, and 9. A complement is everything else that is not in A. Everything that's not in A. Not just including set B, everything. Everything, we're using all the numbers we chose so far. Everything that's not in A. Is this easy or hard to understand? Not understanding what? It means everything not in C. It's a notation to not in C. We're looking at elements. We're describing elements because this is going to help us determine probability. Yes.
It's on military plan.
13. No, no, 13. Yeah, it's 102. Best practices. Let's look at it. Let's look at it. We're going to do a couple of examples. Okay. Flip it over to the back side. For this, we're describing this upper left portion right here. We're going to go ahead and do this one. We're going to show a Venn diagram. Hopefully that will help some of you guys out. I think it will. Is D a subset of A? Meaning, are all elements in D in A? Let's write it out. D is going to be 2, 4, 6. What are the elements of A?
1, 2, 3, 4, 6.
1, 2, 3, 4, 6, and 12. Are all the elements in D in A? D has 2, so A has 2. D has 4, so A has 4. D has 6, so A has 6. Yes, that is true. D is a subset of A. As long as you show that. Elements correspond in one part to another. Now, we're going to go ahead and do the Venn diagram because this might be clear for some of you guys that need the extra help. This is an easier way to look at it. Venn diagram starts out with 2 circles, right? So we're going to go and draw those 2 circles in. And we're doing the Venn diagram for set A and set B. If they overlapped, that means they intersect. That means they are both in each element. So let's look at A and B. What numbers are in both A and B? 2 is definitely one of them because they're both in A. 4 is in both A and B. 6 is in both of them. And 12 is in both of them. That's probably the hardest one to do out of all of them. What are the remaining elements of A? 1 and 3. So we're just going to write it in the 1 and the A element side. What are the remaining elements of B? So we wrote that out. What numbers are we forgetting? Numbers go through 1 through 12. What are we forgetting? What's not in any of those sets? 9 and 5's not in there. 5, 9, and 11. Okay? So make sure I'm doing this right. Okay. Are we forgetting 7? 7's not in there either. So it's on the outside. Absolutely. With this, we're going to be able to calculate our intersections and our unions. What is in both A and B? What's in A and B? 2, 4, 2, 4, 6, 12. Does this visually help you see it a little bit better? Okay. A little bit? Again, this is why I'm showing you this one. There's 2 ways of doing it. I'm showing you both ways, whoever, whatever. Some people liked it the other way. Okay. Union, what is in A or B? We're looking at everything inside of our circles. So what numbers are inside both of our circles? 1, 2, 3, 4, 6, 8, 10, and 12. Everything that's on the inside of this constitutes being in our circle. Our last one here, A complement C. What are in A? What elements are not in A? 5, 7, 8, 9, 10, 11. Everything else that's not in A is our A complement. Easier to see? Okay, we'll do one more. We'll try to practice this. I get that this is hard. Because depending on how I ask you depends on your answer to your questions. This is what makes probability difficult. But if you can clarify what I'm asking for, it makes everything easier. Let's look at another one. Is B a subset of A? Is B a subset of A? Well, B's elements are going to be 2, 4, 6, 8, 10, 12. What about elements of A? 1, 2, 3, 4, 6, and 12. Are all B's elements in A's? Which one are we missing? Well, 2's in 2, so we're good there. 4, we're good here. 6, we're here, we're good here. 12 is in there. What 2 elements are we forgetting? Again, we're just showing you. So no, this would be not a subset. This would be no. Not all elements are in A. Not all elements are in B that need to be in A. So we say no. Creating the Venn diagram. Does the Venn diagram help you guys out? Let's do it. Sorry, my circles are oblong, but it's okay. A and C. What's the easiest one to do first, or the hardest one to do first that we want to get out of the way? Intersection, right? What are in both of them? Let's look at A and C now. So I'm going to kind of erase this for you guys. I'm going to kind of erase this. So what are in both A and C? Oh, come on. We have 1. Oh. We have 1. So 1's in those. Absolutely 3 is in both of those. What else, Mr. Johnson? That's it. 1 and 3? Is that it? That's it. What are the remaining elements of A? 2, 4, 6, and 12. So we write them 2, 4, 6, and 12. What are the remaining elements of C? 5, 7, 9, and 11. What are elements that we didn't even write down that still need to be included? 8 and those go on the outside. Those are not part of any of our sets, but they're considered our universal set, which is everything inside of our box. What's the intersection? What's in both A and C? 1 and 3. What is in the union of A or B? No, union.
1, 2, 3, 4, 5, 6.
Everything that's inside of those boxes. Okay.
So
Everything minus 8 and 10. So 1, 2, 3, 4, 5, 6, 7, 9, and 10, right? Or no? 11, 12. And do me a favor, just so we can kind of keep on with this idea, change this B of C to C of C. Just because it makes no sense that we're introducing B when we didn't even do B. What are the elements not in C? That's in C, right? Everything is here, right?
2, 4, 6, 12, 8, 10.
Yep, it's everything not in C. So 2, 4, 6, 8, 10, 12. Is that hard? Does that make more sense? That's how you want to perceive these. If it helps you draw this out, draw it out. Because we're going to pull from this. We're going to pull from these events. These are what we call events. Probability is what we call event probabilities. Okay, do me a favor, do the one to the bottom left. Just do the one to the bottom left. How much more time do we got in here? Perfect. Enough time. Try that one to the left. Just try it, set it up. The more you practice on it, the better it become. Has anyone played the Angry Birds Revolution, the Evolutions? Is it good? It's broken? Oh, it's broken. You should. Oh, yeah, there's these. So listen. What about one? No, look at the elements that were on. You're looking at the new set.
Yeah, I am. It's no left. It's only 78.
What are you're using this one? Oh, no.
It's a left.
Yeah, so A, B, A, B. There's one here. Oh, some of that is in there. No, no. This one. One. Well, there's present. Your earphones. I'm not paying attention. Is D a subset of A? Why is it not? Not that. What are all the elements of D in A? What elements of D do we have? Does it exist anywhere in this? I don't mean it.
8 and 8, but it's 6.
It's a 6? So none of the elements that are even in D are in A. So no.
Oh, so we're drawing different lines and
Yeah, it's not DNA. Are elements of A and B? What is in both A and B? 1. We have 3 that share. We have 5 that share. And we don't have 6. Then we have 2, 4, and 6. Our B will be 7 and what are the elements that we don't have written down? 8 and on the outside. So that's how it should look, right? Intersection be 1, 3, and 5. The union seven, 8, 9. What is not in A? 7, 8, 9, 10. No set. Do me a favor, circle the top 2. Circle the top 2. If you want more practice, do the rest of them. You can just do the first 2. Top 2. Bye, guys. We'll see you guys. Bye, chat. I'll see you. Have a good one.